Hey everybody, this is Morgan. So we are on page 4 of the Unit 1 outline for Honors Chemistry. And today we're going to start looking in depth at how we use math for chemistry. Let's practice with a little bit of Sig Fig work. So the measurement 101 would have 3 significant figures. The 1 and the 1 count automatically because they're non-zero digits. And this 0 counts because it's a 0 between non-zero digits. Now, the number 97 has 2 sig figs. 2 non-zeros, not a big deal. C gets a little interesting. 1010 has 3 sig figs. This 0 is called a trailing 0. And because there is not an explicit decimal point there, it does not count. Now I realize that you have perhaps been shown in math classes that you can just have an implied decimal point at the end of a number, okay? But that's not the case here. It would have to be very explicitly stated, okay? Now, 970.0 is 4 sig figs. This time the 0 counts because there is a decimal point present. So this 0 and this 0 both became significant because of that decimal place. 0.007 has 1 sig fig. Leading zeros will never be significant with a decimal or not. All they're doing is helping you understand the magnitude of the number, whether it's very large, very small, etc., etc. 0.0070 has 2 sig figs. This 0 is significant because it is a trailing 0 that is following a decimal point. Okay? These are leading zeros up front, which are never significant. 0.00701 has 3 sig figs, the 7, the 0, and the 1, but not the leading zeros. 12 has 2 sig figs, 15.0 has 3, and 10 only has 1. Okay? So you're going to be practicing this in your homework for a couple of nights. You'll get pretty good at it. So I'd like to talk just for a moment about this 10. What does that 10 mean? That 10 means there are approximately 10 items that we have counted, so to speak. Now, it might be 7 or 8 or 9. You're looking out at a crowd of people and you think there are about 10 people there, but you actually haven't counted them. Now, if you went through and counted every single person that was there, and you know that there are exactly 10 people, you would put the 10 with a decimal point, which would give it 2 sig figs. Now, because we're talking about counting people, it's never going to be a 10.2. Can't have 0.2 of a body, so to speak. Okay? But if we have something, say apples, and we've cut one in half, we might have a 10.5. Okay? So the significant digits are based upon the uncertainty in how we have taken the measurement. And a better instrument, okay, can measure with more precision. Okay, so when we talk about precision, that means repeatability. Okay, so we have accuracy, which is whether it's correct or not. And then we have precision. And precision is telling us the number of sig figs, or the repeatability of our measurement. Okay. Rounding. You've learned about this all the way back in elementary school. We're going to round each of these to 3 significant digits. The 7, the 3, and the 2 are all significant. Okay. The next number is a 3, which means we don't round up. 732. 0.231, those are all significant. The 4 is not. So 0.231, 4 is less than 5. We don't round up. 1578. So 1, 2, 3 sig figs. 8 means I have to round up. 1,580. Okay? Now, 732.5, I'm going to round to 733. Now, when it is a 0.5, I typically round up. You can theoretically round down on a 0.5, okay? Often what I will tell students to do is, if it is in your best interest to round up, round up. If it's in your best interest to round down, round down. There have been a lot of silly rules I've seen over the years about how to handle that, okay? But typically with a 0.5, I'm going to round up. 0.007667. The leading zeros are not significant. The 7 and the 6 are. The next number is a 6. 0.00767. And here the 1, the 5, and the 7 are all significant. So 158,000. That is a comma, not a decimal point. Okay. Now, we're going to deal with numbers that are very large and very small. So often we're going to be working with exponents. And I think from your algebra classes you would know this, but as a general statement, 10 to the a times 10 to the b is equal to 10 to the a plus b. 10 to the a divided by 10 to the b is 10 to the a minus b. And 10 to the a raised to the b power is 10 to the ab. And we'll actually end up using that a lot, although most of the time on calculators, but we still need to know what's going on. Okay, 10 squared. 10 squared is 100. 10 squared is equal to 10 times 10. I think you know that. 10 cubed is 1,000. Okay, 10 to the negative 3 is 0.001. So anytime you have a positive exponent, it's a big number. A negative exponent's a small number. 10 to the second times 10 to the third, we're adding them together because it's multiplication. That's 10 to the fifth. 10 to the fourth times 10 to the seventh, we add them together. That's 10 to the 11th. 10 to the ninth divided by 10 to the 3, we do 9 minus 3, 10 to the 6th. 10 to the 4th divided by 10 to the 7th, 4 minus 7 is a negative 3, 10 to the negative 3. We're multiplying, so we add the exponents together, but they're both negative. Negative 3 plus negative 8 is 10 to the negative 11th. Okay, that is page 4 of the outline. When you tune back in for page 5, we're going to do some more math. Thanks for tuning in today. This is Morgan signing off.